So I started implementing a new model, precisely the transformer. And in today's video, I like to specifically explain about one of the layer used inside, or one of the layer used in the beginning of the model, which is called embedding. So as always, I load the data sets. By the way, the task for this model is just simple NLP. So this is the data. So what I mean by NLP, it's just it's like Chat GPT, where given some prompts or inputs, the model has to output most appropriate expected sentence. So for example, I think you guys already know, but given some kind of input like, can I help you, the model has to output the next dialogue in the data set in this case. So this is the data set I'm using, this simple dialogue type data set, and we pass this data set to this function. This function converts, so the data sets are in strings, and the model are expecting inputs to be in integers. Yeah, the integers. So this function converts strings into some numerical values. So for instance, if one of the data set has a sentence like "I love my cat," this function converts this sentence or each word into unique IDs. I have a video specifically explain about how this function works. So, and how does it pick unique IDs for each word? They pick from what known as vocabulary list. This function creates list of vocabularies which are sorted by frequency of each word appears in the dataset. So word like I or A placed in has high frequency of appearing in the dataset. So these I or these word like and are assigned pretty big numbers, and so each numbers with each word are assigned each unique IDs. So, and this is called vocabulary list. Yeah, vocabulary list, and we pick. So we pick word from that list. That's how this function converts strings into unique IDs. And ignoring this code, we pass this converted unique IDs into this train function. And this is the function. These are just hyperparameters, and this is just batch train, like preparing slicing the inputs into each batch. So this is the function I wanted to explain specifically. So what is embedding? It's not kind of like pre-processing we just did using text vectorization, but I don't think it's called pre-processing, but kind of like pre-processing. But however, this function was given unique IDs, right? So we sliced these unique IDs into batches, and we passed to this embedding function. And this embedding function converts these unique IDs into vectors. So each unique ID are converted into each vector. So I like to. So this is an example code showcasing how this function works. So this is the input to the function, and I want you to imagine these three integers as a sentence. So this is one sentence and another sentence, and each integers are words. So in this embedding function, we convert each integers into a vector, and the number column is decided by, and the number of column is called embedding dimension. So this is how big each vector would be. I set it to 3 for this example. And this is another vocabulary size. So this vocab size corresponds to, so I said in this function, inside this function, they create vocabulary list. In this project, I set it to 5,000 because if I don't set vocabulary size in this data set, they are like 20,000 or 70,000 unique word inside this data set. So if I use all the words, the training time would simply increase, and maybe the model would be it would be hard to generalize to the data set if the number of vocabulary size are big. So anyway, so this vocab size corresponds to number of vocabulary list used in this function. But this small example I chose size of 10, and in this function they first create a thing known as matrix, embedding matrix, which are size of vocabulary size by embedding dimension. So we pick vectors from, so this is kind of like a list that we could pick vectors. So for this sentence, so for this word in this sentence, I have to pick some vectors for each integers. So let's say, so for this integer, we look up this list, and this is kind of like the index for this matrix. So this integer is 0, so we look for index 0, and we just pick this vector. So this corresponds to this. And next, it's 2. So 0, 1, 2. So the vector for this word or integer is this. And this is exactly same. And so on. And this embedding captures semantic meaning of each tokens, including relationships with other tokens. Semantic means idea or concept of tokens. So this is like, so it captures semantic relationships. So it's pretty amazing, amazing, because let's say the king has a vector like this. We've got words, king, man, woman, queen, and each has these vectors. If we subtract man from king and add woman, we get queen, which are exactly same as the output we got from this computation is exactly same as the vector for the queen. So it's pretty, and this is how embedding uses uniform distribution, where most of the values are close. And also, embeddings are either trainable or untrainable, meaning if it's trainable, I could train the embedding, this. So in the backpropagation or training function, I have to update this matrix using gradients again. But if you don't want to do it, if you don't want to do that, we have pre-trained embedding matrix called word2back. So I think this is, I don't know which one is common, but I just want to create my own embedding matrix. So I'll go for trainable one. So yeah, anyways, this was just about explaining about embedding. So I guess this is it for today's video. Thanks.